This next example ties into some of our previously worked money examples. So in the off season, the Brownsville Zoo charges $10.75 for a child's ticket and $16.50 for an adult ticket. On a particular day, 527 people visited the zoo, and the ticket fees collected totaled $6,665.75. How many of each type of ticket was sold? Since they just asked how many of each type of ticket, they just told us our variables. You can use C and A if you want, but most of my students are more comfortable if I stick with X and Y. So X is going to be my number of children's tickets sold. While Y is going to be my number of adult tickets sold. Now that I have my variables, we can go back through and write our equations. In the off season, the Brownsville Zoo charges $10.75 for a child's ticket. So we're going to have 10.75x and $16.50 for an adult ticket. And right now we're working on a money equation. On a particular day, it says 527 people. We're not going to use that 527 with this equation because that's money. So that 527 is going to go in a different equation where we talk about the number of people. So let's figure out how much we spent, or not how much we spent, how much did the zoo bring in? It says the ticket fees collected totaled are $6,665.75. We need to finish out the equation for the number of people. Number of people, we had children and adults, and everybody has to buy a ticket to come into the zoo. We know that X is the number of children tickets sold, so X is the number of children, and Y is the number of adult tickets sold, so Y is our number of adults. Now that we have our system of equations, we can go ahead and write this in AX equal to B form. Remember, if you do not see a coefficient in front of your variable, it is a 1. So for our A matrix, we're going to have 10.75, 16.5 in the first row. You could put 50 if you want. In the second row, we'll have 1, 1. Our X, our variable matrix, will be XY, and our B matrix is what we're equal to. Be very careful. If you started with your money equation in the top row, you have to make sure that your money answer from B is in the top row. Now, you could have written this differently. You could have written X plus Y equal 527 first, which means that these two rows would flip-flop, as would those two rows there. But that's okay. You can have these as long as the coefficients are in order and you have it equal to the right number on your B matrix. So you could have these flip-flopped. It's all right. Now that we have our AX equal to B form, we can find A inverse, because remember X is equal to A inverse times B. So if we are finding A inverse, remember, since we have a 2 by 2, we can use Kramer's rule, 1 all over AD minus BC, our determinant, times what I love to call our crazy matrix, where D and A flip-flop, and we negate on the backswing. So negative B, negative C, but nobody moves places. If we're looking at our fraction, we're going to have 1 all over. Remember, you can label our A matrix with its elements. Little a is going to be 10.75 times 1, which was D. B is 16.5 times C, which is 1, times our crazy matrix. In our crazy matrix, the 1 and the 10.75 flip-flop, and we negate on the backswing, so -1, -15.5. If you take the 10.75 minus 16.5, you wind up getting 1 all over -5.75 times our crazy matrix. And then you need to distribute that fraction all the way through. So you can either multiply each of these elements in our crazy matrix by 1 all over -5.75, or divide each of them by -5.75. Same thing, but when you flip back to having fractions, you should be getting that A inverse is equal to -4/23, 66 over 23, working in the top row, 4 over 23, and then -43 over 23. So we found A inverse. Now that we have found A inverse, we can solve our equation. Remember, X is equal to A inverse times B. So we're going to take the matrix we just found with all of the fractions, and we are going to take that times our B matrix, which was our 2x1 that had the money and the number of tickets sold. That's 6,665.75 and 527. Since we're taking a 2x2 times a 2x1, we are going to end up with a 2x1. You don't have to do the line in between. It's just there to help keep things separated. They're both in column 1. Top row will be row 1. Bottom row will be row 2. First multiplication of RC COLA, we're going to have -4 over 23 times from our column the 6665.75 plus 66 over 23, should have left myself more room, times 527. And now that I have taken row 1 times our entire first column, we're going to do row 2. So I'm going to have 4 over 23 times the 6,000 and change plus -43. That should be over 23. I don't know why my 3 looks like a 5 there. There we go. Times our 527. And you should get 353,174. Remember, this is little x, little y in our big X matrix. Can't stop here. You have to explain what you found. So our last step is that X is going to be 353 children's tickets or children tickets. And Y is 174 adult tickets. Always remember to explain your answer and what you found. Don't do all of this work to only wind up having people not understand what you're trying to tell them.